You've seen that when spacecraft come back to Earth, the heat dissipates the kinetic energy of the craft
This is where the Earth's atmosphere is doing the work to slow us down.
until it can just deploy parachutes and land
Gently
smoothly.
waft down
That-
to
correct.
the Earth's surface.
Unless you're Russian.
In which case, you just crash into the Earth.
They don't land in water.
That's right.
They land on dirt,
Yes,
okay?
because we are Russian.
People tend to think that this re-entry
Mm-hmm.
is some very scary part of the trip, and we wish we didn't have to do this, but it's a necessary evil of coming back to Earth.
Well, I mean, it's easy to see why you would think it's a scary part, because every time they show anything coming into the Earth's atmosphere, it is on fire.
It's on fire. Right, but you're thinking, oh my gosh, it's too bad we have to go through this.
Right.
No, that's the wrong attitude.
Ah,
We are glad we're going through it.
okay.
You know why?
Mm.
It means I don't need fuel to slow down.
Oh, there you go. That's right. Because when you land on the moon, you gotta.
Yeah, you need retro rockets so that you land smoothly.
Right.
There ain't no air on the moon.
Exactly.
So re-entry of Earth's atmosphere is functionally aerobraking.
Nice.
How to take your energy of motion and deposit it somewhere else.
Using the atmosphere as brakes.
As brakes. Otherwise, the Apollo astronauts, in their case,
Mhm.
or anybody, would have had to have carried fuel from their original launch pad to the moon back to Earth so that they can slow down.
Right.
So the early heat shields of the Apollo capsules,
Right.
and others, but were ablative. So they were layers like an onion
Nice.
of material that would burn.
Okay, so you're burning off layers.
Good, right, exactly.
Brilliant.
And the layers are very insulative. So the outer layer, when it burns,
Right.
it burns completely, and then the next,
The
layer,
next layer burns.
kicks in.
Right.
Okay, you don't want to burn the whole thing all at
Yeah,
once.
because
That's not going to work. Okay, so it was an ablative heat shield, and what it meant was if you just come out of orbit, you're going 5 miles per second, 18,000 miles an hour,
Right.
to go to zero. But if you're coming from the moon, you're re-entering at 7 miles per second.
Wow.
Okay, that has twice the energy as 5 miles per second does.
Right.
You know how you know that?
No.
Take 5 and square it. What do you get?
25.
Take 7 and square it. What do you get?
42. $49.
Thank you. Okay, so 49 is twice 25, basically.
Okay, basically.
So energy goes as the velocity squared.
Nice. Okay.
That's called the Earth's escape velocity.
Right.
So if you fall towards Earth from very, very far away, by the time you hit Earth, you are going to escape
the
velocity.
escape velocity.
Because that's the velocity you needed to have gotten to where you were in the first place.
So
It's
okay.
symmetric that way. It's very beautiful
That is very
in the
cool.
equations.
Is there a limit to that velocity is there a terminal velocity?
Yeah,
followed?
7 miles per second.
That's it.
If you fall from the edge of the universe to Earth,
Right.
you'll hit Earth at 7 miles
7
per
miles
second.
per second. So that's it.
That's it.
Woo!
If it's Earth gravity that's
Right,
pulling
that's
you.
the gravity.
Because far
Right.
away is very weak.
Right,
You're not
exactly. It's
sailing
no,
very
no
high.
big deal.
Yeah. So in other words, yes, if you fall from the edge of the universe, you're going to hit exactly Earth's escape velocity. If you fall from the moon, as far as the equations go, that is tantamount to the edge of the universe.
Right.
okay?
Might as well
Most
be.
of the energy that you're going to acquire from falling to Earth happens in the last bits, not in most of the early stages.
Okay,
so
gotcha.
so that's why it's loose, but it's accurate enough for the example. So the astronauts probably went 6.8 miles per second
Okay.
to get to the moon.
Oh,
but it's
that's
close
nothing.
enough to 7. Right, it's close enough to 7.
That's
So the point is, this velocity squared,
Right.
what's the first equation you ever learned in school?
I don't know. That's
Equals mc squared.
That's
Of
true.
course you did.
That's true.
What is the c in that equation?
It's a constant of the speed of light.
It's the speed. And what are we doing with the speed? E equals mc
square.
squared.
We're squaring
We're squaring it.
it. Right.
And what's on the other side of the equation?
Energy.
E. So
Right.
the energy goes as the velocity squared.
Look at that. And that's just
You've known that from
and
birth.
didn't even know it.
You didn't even know.
I didn't even know I knew that.
That's right.
Look at that.
There you go.
That's awesome.
Okay, so you have to dissipate twice as much energy. So the shields on the Apollo capsules that came back from the moon
Right.
were at least twice as thick.
Gotcha.
And you just ablate.
You're peeling them
You're
off.
peeling them off.
Just peeling
so
them
it was
off.
very easy from an engineering point
Right.
to increase the heat resistance of the capsule.
Yeah, you're just putting on more layers.
Just putting on more layers.
Yeah, you don't even
exactly.
have to change the material or anything. Just put
Exactly.
on more layers.
Okay, so
Smart.
now in modern
By
times,
the way, that's brilliant.
in
God,
modern
that's-
times they use the material in the shuttle tiles.
Yeah, we saw that.
We saw the shuttle. The
Yeah,
shuttle,
we
right?
went to Los Angeles. We saw the California Science Center.
Yeah, the Endeavor.
The Endeavor, that's
is on
what it
display
was. The
there.
Endeavor.
It's in captivity
Right.
in the California Science Center. So those are, it's not ablative because they want to reuse
Right.
materials.
Right.
So this material, you could take a blowtorch to it.
Right.
It's red hot. Put the torch down, return to it, and it's room temperature.
That's really cool.
Yeah. So it dissipates heat rapidly.
Right.
As it gets hot, it's radiating it away while it gets hot, like in real time. So
Oh, that's
it's a
cool.
beautiful thing.
That's very cool.
So now you're in orbit, you want to get out of orbit.
Okay.
You need some kind of thing to slow you down a little bit
Right.
so that the atmosphere can kick in.
Okay.
So you slow me down a little bit, I drop to a lower orbit
Right.
where there's a few more air molecules.
Right.
Now the air molecules are
Now
hitting.
they're hitting me.
Okay?
Right.
I don't have to use my engines anymore because you're hitting air.
That's slowing me down.
Slow you down a little more where the air is even denser. Slows you down
A
even
little
more.
more.
Even denser. Slows
Right.
you down more. This is a runaway process. You want to do this
Mm-hmm.
where it's not going to hurt anybody.
Right.
Earth happens to have nearly a third of all of its longitude spanned by the Pacific Ocean.
Nice.
There's Hawaii in there and the Galapagos
Oh,
and a couple of islands.
Right. Nothing we really need.
No, stop.
Yeah,
So, but the total area of non-populated ocean
Right.
is huge.
That's great.
So, you start your deorbit at a place where you then plunk the thing down in the
In
Pacific.
NASA's toilet.
The Pacific is the great toilet bowl of space. Yes.
Unless you're Chinese. In which case they say, whatever happens.
So what happened with the Chinese boosters
Yes.
was they did not have a means to control their deorbit.
Right.
And they were just sort of ambling wherever they happen to pick up enough molecules to drop them. That's where it is.
And we got lucky.
So you want to have a little bit of fuel
Just a little.
to tell it when to start that deorbit and then drop it in the Pacific. And if you don't, it's actually irresponsible.
Yes. Yes. Yeah,
Okay.
yeah.
And that happened with several Chinese boosters and rocket parts.
Right.
Right.
Okay.
Right. So that's all deorbiting is.
That's really cool.
It's why you need fuel to land on the moon,
Yeah.
but you don't need fuel to land back on Earth.
Because Earth's atmosphere is your braking system.
Aerobraking.
Aero
Treat it
braking.
as this is a beautiful thing,
There
rather
you
than
go.
oh my gosh, will they survive? I don't know.
Well-
It's dangerous.
Hey, Chuck Nice here. You know, generally, I'm known as an upbeat, happy, smiling guy, but I have a confession to make. For a long time in my life, I was faking it. I was hiding behind a smile because I didn't want people to know that I was depressed. I also felt ashamed and stigmatized, but then I decided to reach out for help and talk to somebody. And I found out there was no need for me to suffer and be alone. The professionals that were helping me made me realize that it wasn't a me thing, it was a chemical thing in my brain. And that allowed me to get over the stigma and find a solution and treatment that actually worked for me. So now, when you see me smiling and happy and upbeat, it's because I actually am. And that's why I want to encourage any of you who might be feeling similarly to how I once was to go out and seek help, because you're not alone. Thanks to our sponsors at BetterHelp, in just a matter of days, you can now get set up with a licensed therapist who is trained to listen and provide you with helpful, unbiased advice. And the best part is, you can do this all from the comfort of your own home. Whether it's through your computer, phone, video chat, or messaging, it's just that easy. Visit betterhelp.com/StarTalk or select StarTalk at sign up to receive 10% off your first month of finding a solution that works for you. And from all of us here at StarTalk, we wish you well.
One last thing.
Yes.
The space probe Cassini,
Yes.
which was sent to Saturn.
Saturn.
Spent 13 years orbiting Saturn, visiting
right.
moons,
Taking pictures,
hanging
doing
out,
all kinds of good
taking
stuff.
pictures, and then we were done with it.
Yeah.
So you know what we did?
Yeah.
We deorbited it.
Nice.
Okay, into Saturn.
Okay.
Okay. But it didn't have heat shields.
Okay. Oh! So it burned up.
Vaporized.
Look at that.
We didn't want it accidentally slamming into one of Saturn's moons that
Right.
later on we want to see if there's life there.
Right.
For all we know, somebody sneezed on the spacecraft
Right.
and it goes to the,
And we killed all the life on a Saturn moon.
with our sneeze
With
virus.
our sneeze virus. Little.
So that's a case where it was deorbited, but with no hope of survival.
Gotcha.
Now, when it's time to take the space station out of orbit,
Okay.
that's a big mama jama.
That's huge.
Do you realize the space station has the area? It's the extent of a football field.
I did not know
It's
that.
huge, but when you include the solar panels
Okay.
and all the modules,
All of it together
all
as
of
a
it together,
football field.
all of it together.
Wow, a football field in space.
Yeah, there'll be a day when we're done.
Right.
We are in the
Now, do they
international
bring that
partner-
whole thing down at once, or do they? Or
It's
is
not
it-
designed to be brought back in one piece.
Oh snap!
If you're going to deorbit any of it or all of it, you're going to plunk it into the Pacific
Right.
as we did everything else.
And not the Chinese way.
That's what the Chinese.
We're gonna do it. We're gonna do it American way. American. Do this right.
And keep it. It's been up there for 25 years, something like that.
Look at that.
Yeah, I know. So we're proud of it. But there comes a time when we have better technology, better computing, better materials,
Right.
better everything,
Right.
and we'll do it.
So that means we got to put another space station up there.
Possibly China's already making a
Oh
space station.
no!
Yes, they are.
No.
They're making their own space station.
Listen, I'm not
You know why?
trying.
Because they were not invited to participate in the International Space Station.
Well, then that means that we got to go ahead and do our own thing.
I'm just saying they weren't invited and they went off on their own.
You know why we didn't invite them? Because we know that when it comes time to deorbit, they're just going to crash it wherever the hell they want. Okay?
Was that why we did this? Okay. So it wasn't the cited human rights violation.
No,
or anything.
exactly.
No, it wasn't any of that.
Right. None of that stuff.
Will you allow me one conspiracy theory?
What's that?
I don't think we really cared about their human rights violations.
Okay.
Because every country's got some issues, right?
Oh, no.
All right.
Everybody got problems.
Everybody got problems.
Everybody
Okay.
got problems.
I think we knew that if we didn't invite them, they would go up and do it all by themselves
Right.
and create their own space program.
Okay.
And if they did,
Yeah.
that would create a space adversary to us.
And now we can continue to do what we got to do.
Exactly.
Right.
We
Yeah.
got the just like we did with Russia,
Yep.
the Soviet Union.
Right.
We had a space adversary.
Yep.
That's my one little conspiracy.
Well,
theory.
listen, I'm going to give you that. I don't
And then
think
they
that's
say, oh, the Chinese are doing it, so we got to do
now
it
we
too.
got to do it too.
Congress writes the checks.
Hey, look at commercial space right now. Just based on what you said, we used to hitch a ride with the Russians. Now all of a sudden, we got this whole
A whole
burgeoning
thing.
industry.
The
called,
whole thing.
What-
And by the way, China said they want to go back to the moon, and we said, it's
guess
time.
what? We already there. We're already there.
No, we got the Artemis program. We're going
we got
back to
Artemis.
the moon.
We're going
All
back.
of a sudden, this blooms out of nowhere.
Yep, there you go.
The fertile ground was we have an adversary,
Right.
a friendly foe.
A
is an
friendly foe.
is an
That's it.
adversary.
That's what we
Because we're,
need.
of course, trade partners with China and
Yes,
everything.
exactly.
So there it is.
Yep. Now, if only Taiwan gets a space station. A space station.
All right, that's all we got time
there
for.
you go.
This has been yet another explainer. Thanks, Chuck.
Oh,
Always been
no,
here
that was
for it.
fun.
All right, Neil deGrasse Tyson here for StarTalk. And by the way, we are recording in my office.
A cosmic crib.
I don't think the authorities would sanction that.
Gotta go for it.
In my office at the Hayden Planetarium of the American Museum of Natural Histories, otherwise known as
The cosmic crib.
All right, Neil deGrasse Tyson here. Keep looking up.